I will go grab the then.
Can we go grab a gun?
Yep. Start with 20 rabbits, triples every year, 5 years.
I just redid it.
That's the time.
Okay, awesome.
Can I go up there right?
Yep. Write down your population, and the other person can grab it.
Population isn't 60. Yes, it is. It can't be. Look, it triples in 1 year. It has no. It's 60. You can't grab 60. Yes, you can.
Make sure your other partner grabs it.
Let's do that. Me and Dylan have a question. Could you come here, please? What are we at? This is not the right equation. Wait.
Good. Yeah, perfect.
He said it's not. Well, I'm just saying.
What year y'all?
1.
Yeah, so you go to the 1, and you go 6.
Just put a note.
That's okay. That's okay. It's just going to show the exponential.
You gotta go up there and do both. You have to come up with. Are you guys going here?
You're at 0.
Under the 1 and then grab it.
Good. Y'all probably got the hardest
cripple.
one. Trickiest one.
It didn't zoomed in on her.
Okay, so. Yeah, because that turns into the percentage. So you. And then what year is it? Good, this is looking really good. Now guys, I have a question for everybody. It's a math question. What is a number raised to the 0 power? Who says 0?
What?
Who says 1? Who says 0? Okay. So, whenever you raise something to the 0 power, it's always a 1, because if you're doing rates and exponents, and you're going to multiply it by itself, another term, you can't multiply 0 by anything and get actually a whole number. So, it's always going to equal 1. Awesome. So, let's see if y'all are right. Yep. Y'all are really good. So, this is the exponential growth of rabbits over time. Okay. Now, I can't mention exponential growth without talking about exponential decay. What does the word decay mean?
Decrease.
Decrease, to go away. Good. So guys, the formula for exponential decay is basically the same as exponential increase, except for whenever you're increasing by a certain percentage, now you're going to be decaying by that certain percentage, okay? So instead of 1 plus the rate, it's going to be 1 minus the rate, okay? Now this is just an example problem right here, guys. So this is in real life where you would use this. So, nope, you don't have to write this down. From 1982 through 1997, the purchasing power of a dollar decreased by 3.5%. Y'all need to know that the value of the dollar decreases. What does that mean when I say the value of the dollar decreases?
Decreases worthless.
It becomes more worthless, okay. Yes, it's just that you're going to have to use more money to buy stuff as the buying power of the dollar decreases, okay. That's why it's really good to invest in stocks, which, what happens when you pick a good stock? You make money, power of your dollar increases, good. What is something else that you can buy that always usually increases?
Gold.
Gold or metals?
James.
Land? Okay. But the value of the dollar does not increase. So, using 1982 as the base for comparison, what was the purchasing power of a dollar in 1997? Okay, so y is representing the purchasing power. Let t equal 0 represent the year, which is initially 1982. The initial amount at first was $1, and then use your exponential decay model. So we have, what is the purchasing power of initially the dollar if it decays 3.5% over X amount of years? Okay, so we start off with our $1. We 1 minus, so we have our decay right here, the 3.5% over how many years? So how many years was it from 82 to 97? Good, 15. So once we solve this, let's see, because 1997 is 15 years after 1982, the t is the 15. So now our dollar has depreciated to 59 cents. Okay. So if they say something to you like, you just bought a stock and you are losing 4% of your money every day, it'd be really good to figure out, you know, how much you're going to lose after a week. Like, or if you can't make it to the bank to change your stock market, you know, how much will you lose if you can't make it to the bank for a week? Okay?
Philip bought stuff.
Philip bought stocks.
Would you buy stock in Philip?
Facebook.
Facebook?
I bought one stock.